Right, Fred here is riding a sled in the snow. I've got a mass of 60 kgs. He travels down here, there's no friction. He starts from rest, down to the bottom, and then travels along here. There's no frictional force along here as well. And the first question is, what's the momentum of Fred and the sled at point C? Well, obviously momentum is P equals mv. His mass is 60 kgs times, what's his velocity? Well, we don't have it. We know up here his velocity was 0 to start with, but he's got faster and faster. We don't know what his velocity is, so we need to find that out. The way we're going to find that out is up here, he's got he's up high, he's got gravitational potential energy. This turns into, down the bottom, kinetic energy. And the formula for kinetic energy is a half mv squared. So if we can find out how much gravitational energy he had by doing that, we know that's equal to the kinetic energy you have down here. We can rearrange it to find the velocity. So let's go. Gravitational potential energy equals mgh. In this case 60 times gravity is 10 and his height is 12.8 meters. When you times those together, get 7,680 joules. Now that's 7,680 joules, that gets turned into kinetic energy. So that's how much kinetic energy he has at the bottom. And we know that equals a half mv squared. So let's rearrange it to find v. I'm going to times both sides by 2 and divide both sides by m. That gives me v squared. Therefore v equals the square root of 7,680 times 2 divided by m, which when I put my m in there, which is 60, I come out at 16 meters per second after I've done that working out. So now I've got his velocity. We can now say P equals mv equals 60 times 16, which is 960 kg meters per second squared. Alright, point C here, he runs off the snow onto grass, and now there's a constant friction force and he slows to a stop at D after a time of 6 seconds. Right, what is the magnitude of the friction force as he travels from point C to point D? Right, there's a number of ways of working this out. I'm not going to do them all, but I'll tell you what they are. Way one is you can do F equals ma. First of all, you have to work out what the acceleration is using an equation of motion. Way two, now work equals force times distance. So force equals work divided by distance. The work's the change in energy. That's the 7680, because it changed from gravitational to, well, sorry, it's going to be 7680 of kinetic changes into heat energy as the friction slows it down. So that's the work. The D you don't know, so you'd have to find the D using an equation of motion. Okay, similar thing there. And way three is work out his change in momentum, and change in momentum equals force times time. So then you just divide that by time. And his change in momentum is, his momentum starts here and it goes down to 0, so that is his change in momentum divided by time. So let's just work that way 3 out. It's actually a really easy way. I'm going to go through way 1 as well. So it's change momentum, it's momentum final minus momentum initial. His final 0, his initial is 960, that's minus 960. And using this formula here, we get F equals change in P over T, if we rearranged it. So that's minus 960 over 6, which equals 160 newtons. They just want the magnitude, so just the size, they don't need to put the minus in. That's one way of doing it. I'm going to do way 1 as well. Alright, F equals ma, that's what we're going to go with. The A equals, we don't know. We've got his initial speed, which was 16 from here. His final speed equals 0. and we've got the time equals 6 seconds. So what equation of motion had all those in it? V equals u plus at. So v minus u equals at. V minus u over t equals a, and that equals v16 minus, oh sorry, I've got these around the wrong way. His u is 16, his final is 0. So we've got 0 minus 16 divided by 6, and that equals 2.67, and there's a minus there. And F equals MA equals 60 times 2.67 minus equals negative 160. Again, they just want the magnitude, the size, so it's 160. That's the same answer we got here. If we'd done way 2 as well, we would have got the same answer again. Okay, so there's a couple of ways you could have gone through that one.